We got this area here, pinta-ala, about 400 if we round that roughly. We could also check it from this picture if I remember that I had the lengths doubled, the sides of the lengths doubled there, so I get here it is 11, so the 110, so it divided by 2 it is 55, 55, and the height of this triangle is about, in my scale, about 30 millimeters, so it should be divided by 2, it's 15 about, so 15 and divide by 2, I get about 400. Well, no, well, the error is quite big, but maybe we can believe that we calculated this correctly. About 400 units squared is the area. Then we could also use another method to solve the area of triangle, and it was also shown in this page we watched earlier. Here in this book it is not named in any way, but this formula, do you remember the name of this formula? This is all. What is the name? Do you remember the name of this formula when calculating the area of triangle?
I don't understand the question.
This has a name, this formula. From the inventor of this formula, it comes from. Actually, I guess it was first found. This formula was probably first found in somewhere in India. I think, but this person who has got his name in this formula, he came from Alexandria, Egypt. Actually, he was from Greek, but he lived in Alexandria. In Finnish, we call him Heron Alexandrialainen, or Heron from Alexandria. Heron's formula. I think probably I can't open the Moodle. Let's wait. If it is, it could be open. I don't understand why doesn't it open. There is some problem. Let's take that. In Finnish, I think we usually write this N letter to the end of the name, but I've seen in English text that they use only both are used with the N or without the N. Hero, but it's not the hero as in English, but it is the name of the person, Heron. this Alexandria was a famous city of science long thousands of years ago in Egypt. And this is probably most unknown formula concerning triangles. In this formula we use ABC, so this is useful especially when you know all the sides of the triangle but no angles at all.
Okay.
And this B here is told here. Most usually this B means the perimeter, but in this case it is the half of the perimeter. I don't know why they use the same letter. Of course, sometimes you may find this formula with using another letter for this. For example, S letter is used. But here this B means it is the. Let's see. For example, here is ympyrä. It is circle in Finnish, and here is the formula for perimeter. So the length of this ring. So there is used the letter B from the word perimeter, but here actually it is half of the perimeter, because if we sum these sides, so we get A plus B plus C, and here we must use half of that. If we have triangle like this, ABC, so the formula, it's quite easy to remember, because inside the square root we have this B first, and then we have these brackets here, and in every bracket there is subtraction from B minus A, B minus B, B minus C. So there are all these sides of triangle inside of that square root and inside of those brackets.
You can also skip the B in the formula, right?
Skip?
Skip the B, yeah. Then you put like 1/4 of.
Can you show? Yeah.
I found what you mean. You can skip the B. I don't know, it might be nasty.
Yes,
Yeah,
but it is more nasty, I
yeah.
think, yeah. If you, for example, from Wikipedia, this formula may be written in a different way, but I'm used to this, and I think most formula books gives it in this way. Half of the perimeter. These words here, half, so 1 divided by 2. In Finnish, do you know what is it? Puoli. Puoli. Almost like Poland in Finland. Puola is Poland in Finnish. Perimeter. It's ympärysmitta. This mitta is we may call this also mitta in Finnish, but it means measure, and ympärys is something like something which is around you. So it means that it is the length of this border which is around of this triangle. So this is perimeter, ympärysmitta. We can also use the word piiri. It is also used. Piiri, I think mostly this word in Finnish is used when you are concerning circle. Many times the perimeter of a circle, it's called piiri.
So the perimeter of a triangle, it doesn't matter whether it is a right angle triangle or scale or
This sorry, can you repeat? This formula works in every triangle. Yeah. Not only necessarily right angle triangle. Every triangle it works. Yes. This piiri, in Finnish we have a children's song when they are dancing in a circle form and they are singing piiri pieni pyörii, lapset siinä hyörii. There is this kind of circle and the children are dancing in the circle and they sing that. All sang when I was young.
So
yeah.
The perimeter.
Yeah.
When you look at perimeter, for example, in a circle, a triangle.
Yeah.
Okay. And
so it would be this.
Yes, this is the distance around the triangle.
Yeah.
So if we add all the sides.
Yeah.
We get 1, 2, 3, for example, triangle.
Yeah.
1, 2, 3.
Well.
So that is 6. So
well, actually, you don't have in triangle. You don't have 1, 2, 3.
No, I'm just giving an
Yeah.
Let's say you have like
this.
Yeah, I understand. Yeah.
Yes, exactly. So if you add that is 6.
Yeah.
So that is the distance from the circle.
Yeah. Yeah.
So why are you dividing by 2?
Well, actually, the proof of this formula is quite long.
It's just a proof.
Yeah. It becomes big. It actually, when there is dividing by 2, it shows us that there is something to do with the triangle. Because because every time when you are calculating area of triangle, you every time have some kind of division by 2. So there is half and there is half and also there is half. Yeah. It comes so. But I've done the proof sometimes, and it is not so easy one. It is not so easy. But I have to give credit for this person here on about 2,000 years ago or longer ago. How could he do that in those days? It is quite impossible to understand.
When they saw the whole of their life.
Yeah, probably, yeah. Because actually he was quite how do you say, genius. Because I think he was the first who somehow invented what is the machine? James Watt invented. What is the James Watt invented that machine which used höyry in Finnish. Steam engine, yes. He actually, I think this Heron was actually the first who invented some kind of steam machine a long time ago. They have found some proof that he had some kind of knowledge of steam machine. I don't know if he made that actually, but he had some theories of that. Okay, this is most useful formula if you have if you know the starting values and you know those in the beginning. For example, in this problem, I don't see it so useful because if I have to use, for example, this B, so to calculate this B, I need to use this. Well, A is easy one, but B and C are not easy ones because they are this kind of numbers there and this kind of here. And after that we get this value B, and it comes to 4 places there. And also this B and C come to 2 places there. So to write this formula for this example is quite nasty because I don't have enough space for the row. So we don't take that example now, but if you are using, for example, Excel or some Excel is a good example, because I showed my laptop because I'm using Excel, and Excel in that example I have calculated the area of that triangle with the help of this formula. And it is, when using Excel, it is quite easy because you only have to write those formulas to that table, and it's quite easy. Just pick those numbers there, so you don't have to write anything. But if we take, for example, by the way, in Finnish, esimerkki. Merkki is something like mark, and esi is something esi. How do you? Well, actually, there are many translations for this esi word in Finnish. For example, forefathers, the grandfather and his father, and etc. They are called esi-isä. Isä is father, and esi-isä is that great grandfather. He is called esi-isä. I don't actually understand why this example. Maybe it's come from this X, so someone has thought that in English it is example and this esi is something like that, but actually I've never even thought that where this word comes to Finnish. But let's take an example where we have simple numbers there. For example, A equals 2, B equals 7, and C equals 8. So first we have to do is to calculate the B, or in this case half of the perimeter. So now it is quite easy to calculate. If we count these, add these numbers, we get 17, and divide by 2, it becomes 8.5. I should have chosen the numbers more easy ones. Yeah. So we have 2 plus B 7 plus 8 divided by 2, and we get half 8.5, 8.5. But after this, it is very easy to write the formula, because we only need to get this P, value of P. So I will write it first in the beginning inside of this square root, and then I put multiplication mark and 3 brackets. This is very mechanical way to solve the area. And then I mechanically write these minus signs there. And then I remember that in front of every minus sign I need the value of B. So we will write 8.5, 8.5, 8.5, and then ABC. So I will put 2, 7, and 8.
And I think you can write a many formula.
Yeah.
Because it's multiplication.
So I would say that when you are calculating with to paper, this formula is most easiest one when you have very simple numbers for the values of the sides of the triangle. So it is very easy to write, and you don't need any angles, you don't need to solve any angles, or you don't need to solve any heights of the triangle. You only put them mechanically in this formula, and then you calculate what is the value of it. So we get 6.4371. 6,4371. Maybe it's because if you were not familiar to this formula, maybe it's good to take another example where we have a very simple triangle for which we are able to calculate the area with a more easy way to understand that this formula actually works. So if we have this simple triangle 3, 4, 5, this we call it kirvesmiehen kolmio in Finnish. Kirvesmiehen kolmio. Kirvesmies is carpenter. So this is carpenter's triangle. I don't know if they use this word in English. Carpenter. Kirves is axe. Again, my drawing skills. Is it axe? E?
Yes.
E, like this. This is. I should practice my drawing skills to the next academy. Yeah. And mies is a man, so this means eiksman, and it is the same as carpenter in Finnish. Kirvesmies is the carpenter, and this N ending there means that mies is a man, and something which is man's own, it is miehen, and this kolmio is triangle. So this is this triangle which these carpenters many times when they are building, they check that the building is right angled, so they measure with this kind of 3 meters, 4 meters, and 5 meters, so you can build a right angled triangle with that. So in this case, it is easy to calculate the area of this because we base times height divided by 2, so it is 4 times 3 divided by 2. 4 times 3 divided by 2, it is 6. Or half of the 12.
So why can't we use the first formula also?
This.
No, the other formula.
This.
Yes.
Yes, we can use it also here. So I will taking this example just to check that this gives correct answer. Yeah. So in this case, we actually there is no use to use this formula now because it is so easy to get the area. But let's see that if this works, this formula. So right now B is half of the perimeter, 4 plus 3 plus 5. It is 6. Yeah, 6. Sometimes when it is a long time when you haven't used this formula, sometimes here comes problem that you remember incorrectly that there should be 3 below this line, because it sounds, for example, in this case, it would sound understandable to calculate some kind of average of or mean of the sides, but actually there is 2 every time, even though it is triangle. And now the area is 6 times. I many times write this in this mechanical way because this helps me to remember the formula. So this 6 comes every time in 4 times in the formula, and then these 3 sides. This is 1, this is 3, 3 times 2 is 6, 6 times 6 is 36, and square root of that is 6. Boring example, all numbers are 6's there, but we got the same result here. So maybe after this we believe that this formula works also for not so easy easy triangles one. Okay, and now I will give you some problems to solve by yourself, and let's use this this time which we have left for independent calculation. So let's give you problems. And yes. Problems. No, you don't need to. I will put those assignments you need to send me. I will put in the model there in that place where it is. But because I want to go around and check how you can solve this by yourself. Of course, you can do teamwork. It is every time very good way to practice these kind of things. But I will give you some problems, and in every problems you have to solve every unknown part. So after you get the problem done when you know all the sides of the triangle and all the angles of the triangle and the area of the triangle. So one, you know B is 14, C is 21, and alpha is 34 degrees. And then A10, B 16, C 13. You don't actually need to get everything done today, but I give many problems if you want to practice yourself after these lessons. And of course, every time you may contact me if you need help or you don't understand, or if you want to check if the answers are correct. I will put right answers to Moodle during weekend, but right now I only have them in my Excel.
So now what are we calculating?
Oh, but we have to wait to come.
Yeah, so
Missing, missing.
calculate missing parts of the triangle and the area of the triangle. And round them to 2 decimals accuracy. 2 decimal places is all you can say. Okay. I will end the recording now, so